Okay, so I think you can read that. Hi, Gail. This is me doing a video for you and the folks through CETL and all the faculty. I'm here. I just got back from Boston. When I was in Boston and I saw your emails, like, holy cow. Can I get this done? Probably not, but I'm going to try. So here we go. I'm going to be kind of playing around. I just felt like this was a good filter for the tone, old black and white, and I was actually going to try to do it with no sound. But that was not really working. So anyway, I do want to say, just because I like playing around with these things, this little filter here, this is exactly the truest reaction I had when Gail asked me to do this video, because I do not like to do videos. So, okay, now I'm done playing around with the filters and the face accessories. I'm going to get, hopefully, down to business. If I can get this arrow off my head. Okay. I think it's gone. No, it's not. Now it should be gone. Okay. So anyway, what I wanted to tell you was the one takeaway from when we met in December that I've tried in my class with much success. So a shout out to Dr. O, because I did the dance of the chromosomes. It was totally awesome. And it fit really nicely into my curriculum because in my biological issues class, I allow the students to do research through the theme of a free skate, like back in the 70s when disco music was prevalent and you went to the roller rink and a free skate meant you could do whatever you wanted to on the rink. Well, I let them do that with certain topics. And this idea that they are free to look at the things that are of most interest to them fit really nicely because I played disco music when we got to genetics and we need to know a little bit more about what's going on with our DNA. It was awesome. The best part, I think, seriously about it was not only getting the students engaged, but giving them a tool to take something that's abstract, can't really see it, don't always understand it, but giving them a mechanism for going through mitosis, through cell division, and being able to kind of create a memory tool of what is actually happening to the chromosomes as they move through mitosis. It was excellent and so much fun. The thing that I had shared when we were meeting in December with the folks that were in my group, I used Legos to build molecules to help students understand biological processes like photosynthesis or cellular respiration. And the thing I like about Legos is the same kind of thing. You get to regress a little bit. It's a toy. You can have fun. And the Lego company has done a nice job at taking their Legos and creating a color-coded periodic chart. So you know what each one of these Legos represents with regard to an element on the periodic chart or to an atom. And so it allows students to manipulate, to build a model, to break the model apart so they construct and deconstruct, and they can see how glucose, for example, goes through this change as it's made or as it's broken down in the body or in a plant, whatever we're discussing. I think it's a really cool concept, and I will say that I just got back from Boston, and I had the opportunity to share things like this with other colleagues from around the country who teach biology at the college level, and modeling abstract concepts seemed to be the theme. And I sat in on one colleague's presentation, and she's an anatomy instructor, and she went around her house and just grabbed household items like Saran wrap, pipe cleaners, nylons, pantyhose, tissue paper, streamers, paper plates, balloons, whatever she could find in the kitchen, in the garage, in her junk drawers. And she actually built muscles, different cellular parts, and taught us how to kind of construct, ultimately, skeletal muscles to attach to the model of the human body so that students could see where they attach and then how they move. It was really fascinating, and I thought, geez, if I needed to go to that level for skeletal muscle, taking these common objects that I could find around the house to help students kind of understand where muscles attach, how they move, how they help the body move would be really a cool way to handle that course content. So, in a nutshell, modeling is an excellent way to help thinking become visible, become alive in your classroom. I've had a lot of success with it. I look forward to continuing to think about ways to make thinking become visible for my students through modeling. And if you have any questions, all the way up at Tarpon, glad to talk further and appreciate the opportunity to share a little bit today. Hope y'all have a great morning and afternoon. Thanks so much. Bye.